to Industrial Applications, Programmable Logic Controllers Level 2. This video is about manipulating data. There may be times when it becomes necessary to temporarily manipulate data. For example, changing the program value or current value of a counter of cheese balls on this conveyor line, or the length of time that the conveyor stops. On any program counter or timer, we initially set the program value or program time. But over time, we may need to make adjustments to those counters or timers. This may be due to wear and tear, or because the process has changed. Perhaps the number of cheese balls, as shown, has changed because they are physically smaller and we can get more into a carton. Because the program value here is a fixed constant value, we will need to go offline and alter the programmed value. Okay, looking at this screen, we can see our count up and count down counter has our programmed count at 17. Notice when I move the mouse, it populates with a small pop-up window that says that the data type is a lint or long integer. Notice too that our down pulse is red because it's changing, our QD is red because it's changing, and our CV, that's our counted value, it is also red because it's changing. But our programmed value is not. It is black, which means we can't change it. So to fix that, we are going to have to go in and manually do it. So we're going to go up and disconnect. And then once that's done, I can double click on that, and it's going to ask me if I want a new value, new variable, instead of a number. But I can just turn around and type in the number 24, press enter, and we're changed. Now I can go back online, download it. And we now see that our new program value has been accepted. We now have a lint, data type of lint of 24. Again, it's colored black because it can't be manipulated or changed by anything in the program. Well, that seemed to be successful. But is there a way we could change the value on the fly, as the program's running? Well, the short answer is yes, but we need to change the PV to a variable, not a constant. Alright, so we want to manipulate the variable that's called production count. And it's part of our count up, count down counter. To do this, notice we are in run mode. We're not offline. Now normally if I were to click on this and right click it, I would get variable selector. But when I'm online, it changes to variable monitoring. So I'm going to right click and click on variable monitoring, and we're shown our production count variable. We're in our global micro 850 scope, and we've got our initial value set at 24. Notice it is in black. We cannot change it. This allows that when we first start up a system, we download the program, it's going to download that value. Now we can skip that and say just download it, don't bother doing the initial values, but we're going to manipulate because we may not want 24. To do this, let's just open up our counter and look at all of the different components. So we can actually look at each of these as different bits, which is not a normal way to look at a dent. But we can take advantage of that. We're going to put that in our toolbox and think about that for later. Notice now that we have two set. We have bit 3 and bit 4. This is the binary equivalent to 24. So I'm going to double click on the red 24 under our logical value. And now I can type in our original 17. Notice it's red. I'm going to close this, and down here in our production count it's now 17. That's using the variable monitor. A MOV, or move instruction, takes the value of any other variable identified as I1 and places the value into a destination variable identified as O1. It is non-destructive to the source, but is destructive to the destination. What we mean by that is non-destructive means that the source remains the same and unchanged, but the destination is overwritten, hence they call it destructive. Okay, so here again, we're going to have to go back and do a little bit of programming to make this do what we want. So we have our count up, count down timer. And what I want to do is I want to take the production count, and if I select shutdown mode, I want to change the production count so it doesn't continually build and it will reduce the number. To do this, I'm going to program a new run. So we already have one move instruction, and it is taking the value that we find in that same count up, count down, and we're moving it into a sequence 3 underscore bits. If you followed the program, that's how we're turning on certain outputs. But I want to change this production count such that it's going to change the amount that it counts to, and that will change the outcome of our count value. So I'm going to grab a new run, and I'm going to put a bit, and I'm going to call that shutdown because I have a shutdown sequence over here. Shutdown stop, shutdown, there it is, and I'm going to get a move instruction, which you'll find under move and copy. Now move works on a single variable. Copy works a little bit differently, and it can copy into multiple variables. We will take that in a future lesson when it's a little more advanced. For the moment, we're just dealing with one single variable. So I want to take a move variable, and I'm going to go and select it. Now I have a couple of variables that I've already created. Let's see here, where the micro 850, that's good. And I'm going to filter this by saying I want a dint. No, I'm looking for the name dint data type. Okay, now I can type in dint. Or scroll down and find it. Okay, so I have two that I might be wanting to use. I have empty and I have half. So I'm going to take empty. Go OK. So it's going to examine whatever value it finds in empty, and it's going to place it into our variable called production count. So I'm going to go back to my variable selector, and I want to see what my initial value is for that. I'm going to slide over, and right now my variable empty has no value whatsoever. The one below it says half, and it's set at 12, which is half of 24. So I'm going to give this an initial value. Try this again. Of 0. And I'm going to hit OK. So now, when the shutdown sequence is selected, it's going to take the value of empty and put it into our production count. So let's download it and watch it in action. Yes, change it to run mode, please. Okay, so we're at 24. The count up is not changed. I'm going to initiate the shutdown, and we're going to cover this shortly, but I'm just going to do it the shortcut way. I'm going to toggle the bit, and you can see instantaneously it sent a 0 to our production count. So this would then tell us that our current value is 0, and notice it has also changed our sequence bits 3 to also being 0, all from this one simple move instruction. We're going to talk about toggling bits in a future episode, but for now, we now understand how this move instruction can take data from one spot and move it to another. There are some rules with respect to moving data. The most important rule about moving data is the freight train rule, which basically says you can't put a freight train in an apple. This rule means you are not allowed to mix data types. If the target is a dint, then the source must be a dint. Like for like. Any other attempt will create a build error. Second rule of move instructions is that the last move instruction wins. This means if there are more than one MOV instruction writing to the same destination variable, the last instruction executed will win and overwrite anything before it. Finally, always keep in mind the move instruction is destructive to the destination and may have unintended results, especially if moving negative numbers. Use this instruction judiciously, that is to say, very carefully. To review, you can move data. We can change the value of counters and timers by either editing the value through a program rewrite or edit the program such that the PV or PT is a variable. Once they are variables, we can alter the value by either using the variable monitor while running or by writing logic that will overwrite the existing data. Because move instructions are destructive to the destination, they must be used very carefully. In our next video, we will look at different ways we can manipulate data at the bit level.